Give the next heading, specific properties. Give the next heading, specific properties. Now what is meant by specific properties?
Specific enthalpy, specific
properties per unit mass. Properties per unit mass is called
specific properties.
It's called specific properties. Means whenever there is a word will come specific. That means what? Per unit mass, per kg basis.
Okay, sir.
Please write down this definition.
Yes, sir, written.
Now here the first specific property that we are going to see is what? Specific volume. Specific volume we are going to denote by small v.
Small v.
And how we are going to define specific volume? It is defined
volume per unit mass.
It is defined as volume per unit mass. How we are going to define specific volume? It is defined as volume per unit mass. And what will be the relation? So specific volume will be equal to what?
Capital volume V upon
volume divided by what? Mass. Or in other words, small v will be equal to what? Capital V
upon
m.
Small m.
And unit will be what then? Meter cube per kg. Unit will be what? Meter cube per kg. So here we will get a specific volume.
Yes.
So please write down this discussion. Now we have seen a density. Density is equal to what we can say?
Mass upon volume.
Mass upon
volume.
Volume. Unit will be in what? Kg.
Kg per meter cube.
Or we denote density by what? A rho. Rho will be what? M by capital V in what? Kg, kilogram per meter cube.
Meter cube. Yes.
Please write down this one for density.
Yes, sir, done.
Now if you have seen, what will be the density then? So if you see the relation between density and specific volume, so can we say density is equal to what? See, they are inverse of each other. Here,
yes.
Specific volume, volume by mass. Density is what? Mass by volume. So what we can say? Density is equal to what? 1 by specific volume.
Yes.
Or specific volume is equal to what we can say?
1 by density.
1 by density in their denotation. So rho is equal to what? 1 by small v. Or small v is equal to what we can say?
1 upon rho.
Please write down this discussion. Now, how we denote internal energy? Tell me how we denote internal energy.
With the help of U, capital U.
Capital U. So next term is what? A specific internal energy. And specific internal energy we are going to denote by small u. Internal energy, capital U. Specific internal energy, small u. And it is defined as, how we are going to define?
Energy per unit mass.
It is defined as internal energy. It is defined as internal energy per unit
mass.
Per unit mass. And so small u will equal to what relation we can write down? Capital U by
M.
And unit will become what? Capital U unit what? Kilojoule. And M is kg. So here unit will, small u will become what? Unit of small u?
Kilojoule per kg.
Kilojoule per kg. Please write down these things. Specific internal energy. Now the third point will be what? How we denote enthalpy. How we denote enthalpy?
Enthalpy, capital S, sir.
Enthalpy is denoted by what? Capital H.
Capital.
So
Yes.
here now we are going to see specific enthalpy. So specific enthalpy we are going to denote by what?
Small h.
Small h. And how we will define small h? It is defined as what?
Enthalpy per unit mass.
It is defined as enthalpy
Per unit mass.
per unit mass.
Yes.
And small h will be equal to what? Capital H by m.
Upon.
And unit will be in what?
Sir, kilojoules per kg.
Kilojoule per kg. So please write down
Yes.
discussion related with specific enthalpy.
Okay.
Now the fourth point that we are going to study is what? Specific entropy.
Yes.
How we are going to denote specific entropy?
It is denoted by small s.
Entropy, specific entropy, we are going to denote by what? A small s.
Small s. Yeah.
And small s will be what? It is defined as what?
Entropy per unit mass.
It is defined as entropy
Per unit mass.
per unit mass. Please make the correction here. I have written union. Here it must be unit per unit mass. And small s will become what? Capital S by m. And unit capital. See, the unit of capital S is what? Kilojoule per Kelvin. We have seen while discussing.
Okay.
If you remember our discussion of entropy, see this one. Unit of
Yes.
entropy we have said kilojoule per Kelvin. So
Yes.
specific entropy will become what? Kilojoule per Kelvin, mass unit kg. So unit will
Kg.
become what? In
Kilojoules
kilojoule.
per kg Kelvin.
Kilojoule per kg Kelvin. See the things here. So please write down this discussion. So these are the things related with specific properties. So 4 specific property. But always remember that whenever they said specific means what? Per unit mass. Per unit mass means what? Per kg basis. So we have to consider mass as what? 1 kg in that scenario. So whenever there is a specific word will come, it means mass will become what? 1 kg.
1 kg.
So try to see the scenario here. Now one important note we have to study here. One important point we have to see here.
Yes.
We have to remember this point. All the system in this chapter are what?
All the system in this chapter are
all the system.
isentropy.
No. All the systems in this chapter are what? All the systems in this chapter are closed system. All the systems in this chapter are what? Closed system. And closed system contains what? Here remember what will be there in? And closed system contains an what? What must be there? Closed system contains
No irreversibility.
an ideal gas.
Okay.
Irreversibility is 0 by default, no problem with that. But closed system contains an what? Ideal gas. Means ideal gas must be there in closed system. So remember, all the systems in this chapter are what? Closed system. And closed system contains an what? Ideal gas. Remember this point. And whatever theory we are studying, please try to memorize all this theory properly. Whatever theory, I am giving a single point also, try to memorize that point. Because if you good with this one, you are good with the next 2 questions also. Because this question is a basic question for the next 2 questions, especially question number 2 and question number 8. So please write down this note. Now try to see the scenario here. The next heading, try to see the next heading. Do the next heading. Change in entropy. See the word, see the heading first of all. Change in entropy of a what? Closed system. Closed system containing an what? Change in entropy of a closed system containing an
ideal gas.
containing an what?
Ideal gas.
So this is what? Please give the heading, change in entropy of a closed system containing an ideal gas. And remember, all the systems in this chapter are closed system containing an what?
Ideal gas.
Ideal gas. Now what are the relation? There are two relation for this one, closed system containing an ideal gas. Relation number 1, M CV ln. Ln stand for natural log. Ln of what? T2 by T1 plus R into ln of V2 by V1. This is one relation.
Okay.
And second relation of change in entropy will be what? M CP. CP means what? Specific heat at constant pressure.
Constant pressure.
MCP ln T2 by T1 minus R into what? Ln of what?
V2 minus P2 minus P1.
P2 by P1.
Okay.
It will become what? P2 by P1, and unit of change in entropy will become what? Kilojoule per Kelvin.
Per Kelvin. Okay.
Please write down both the relations. Both the relations are very, very important to us from exam point of view. Generally, each and every question they will ask us change in entropy. Each and every question, generally, most of the questions, 90% question, we will get a change in entropy.
Okay. So this S is a capital S, right?
Delta S. That's why we said, if you are getting a problem with, sometimes for us small s and capital S is the same. We are not able to differentiate that small s and capital S. So see the unit for that purpose always.
Yes, sir. Yes, sir. Yes, sir.
Sometimes we are not able to differentiate because in typing things we can differentiate easily, but for writing things small s and capital S is the same for us. Sometimes means we are not able to differentiate. So for that
Yes.
purpose always try to see the unit.
Yes.
So here capital S we have. Now suppose we want change in specific entropy. Suppose we want change in specific entropy. Change in specific entropy of a what? Closed system
containing ideal gas.
Containing an what?
Ideal gas.
Containing an what? Ideal gas. Suppose we want change in specific entropy of a closed system containing an what? Ideal gas. In that case, what we have to do? So mass specific. What is the meaning of word? So first of all, give the heading. Change in specific. See the word specific here. We added extra word. Change in
Yes.
specific. Now, what is the meaning of word specific here? What is the meaning of word specific? Per kg.
So entropy per unit mass.
Per unit mass. So mass will become what here? In this relation, this mass will become what? M will
1
become
kg.
what? 1 kg. So M will become what? 1 kg. So we will write down, copy the same expression. And here S will become what? A small s, because we are
Yes.
saying. So what relation we will say? CV into ln of what? T2 by T1. See this one.
Yes.
Plus R
R
into ln of what?
V2 upon V1.
V1. And unit will be what? In kilojoule per kg
Kelvin.
Kelvin. Specific. Or another relation of change in entropy will be what? Small s. CP
Smallest equal to Cp into
ln
T2 by T1
T1 minus R
into ln P2 by P1.
P2 by P1 minus R into ln P2 by P1, and unit will become what? Kilojoule per kg
Per kg Kelvin.
Kelvin. So this will be what? Our delta S here, and here also what? We will have another expression of delta S or per kg basis. Please write down both the relations. Now what is the next point? Equation of state for closed system containing an ideal gas. What is the next point? Equation of state for what?
Containing an ideal gas.
For closed
For
system
containing an ideal gas.
containing an what? Ideal gas. So now onwards our discussion entire is discussion about closed system containing an what?
Ideal gas. Ideal gas.
Containing an ideal gas. Please give this heading first of all before going further. Now try to see the scenario. What is the equation of state for closed system containing an ideal gas? We
Yes,
have
sir.
seen ideal gas equation is what? PV
PV
is
is equal to MRT.
MRT. So can we write down PV by T is equal to MR?
Yes, sir.
Now for a closed system, what about M? For closed system, what about M?
M will remain constant, sir.
For closed system, M will remain what? A constant. For
Constant.
a particular ideal gas, for a
PV is directly proportional.
For a particular ideal gas, value of R is what? For a particular ideal gas,
Yeah.
for a particular,
8 points.
no, for a particular ideal gas, value of R will be what? It is a constant.
Yes.
It is, see, 8 point, don't consider 8.3145. 8.3145 universal gas constant. It is same for every gas. But gas
Okay.
constant means for CO2, gas constant value will remain same. For air, it is the same. Means for a particular ideal gas, R is a constant. So it means
Okay.
what? Therefore, for closed system,
PV by T is equal to constant.
so for closed system containing an ideal gas, we can say what? Containing an what?
Ideal gas.
Containing an ideal gas, what we can say? MR will be equal to constant.
Yes.
MR will be equal to constant. So therefore, what it will become?
PV by T
Equal to,
constant.
and it means what? What we can say? P1. Therefore, what we can say? P1 V1 by
T1.
T1 is equal to what?
P2 V2
2
by
by
T2.
T2 is equal to what?
Tn
P3 V3 by what?
T3
T3 and
constant.
so on. Okay, you are getting my point?
Perfect, sir.
Okay. So above relation is what we can say? Above relation is an equation of state. Above relation is an equation of state.
for closed system containing
Equation,
an ideal gas.
equation of state for closed system,
Containing an ideal gas.
for closed system containing an ideal gas. Okay, and it is independent of the process.
Okay, sir.
Means whatever may be the process, okay, it is the same one. So please start writing down from the top all the things.
Yes.
One by one. So this is what all about our basic theory. Now try to see the scenario here. Next point that we are going to study.
So from this theoretical question also comes?
No theoretical question. But you have seen we are writing a lot of theory. Because
No, I
this,
thought that there will be something, at least a theory question also.
no. Whatever the things we are studying, it is only required for the numerical, sir.
Okay, sir.
Okay, and so that's the difference of heat. Here a lot of theory is there. For next upcoming 3 question,
Okay, sir.
Give the next heading. Different
Yes, sir.
processes of a closed system. Different processes of a closed system containing in what?
Ideal gas.
Different processes of a closed system containing an ideal gas. Give this heading first of all. Different processes of a closed system containing an ideal gas. Now, what are the different processes of a closed system containing an ideal gas and how we are going to approach here? So, there are total 5 processes we are going to study here. First process is what? Try to see the listen my word carefully. First is what? Constant volume process. Another
Okay.
name for constant volume process is what? Isochoric process.
Isochoric.
Isochoric process.
Okay.
Second process is what? A constant pressure process. Another name for constant pressure process is what? Isobaric. Bar is a unit of what? A pressure. So
Yes.
iso stand for constant, bar means pressure. Isobaric process. Then third one is what? Constant temperature. Constant temperature.
Process.
And constant temperature process means what? Isothermal process.
Isothermal process. Okay.
Constant temperature process means what?
Isothermal
Isothermal
process.
process. Then fourth point, constant entropy process, or we will say isentropic process. Another name for isentropic process, what we have give, if you remember our discussion, isentropic process is also say adiabatic process.
Adiabatic, okay.
We have seen isentropic means constant entropy, no problem. But another name is what? Adiabatic process. Then fifth one, if it is not in this 4 category, these are the 4 reserved. Our general category is what? Polytropic process. If any process is not fit in this 4 category, then that process must be what? A polytropic process. So please write down the names of these 5 processes. We are going to study these 5 processes one by one.
Okay, sir.
Now, for all these 5 processes, for the
Yes.
above 5 processes, for the above 5 processes,
Yes.
we are going to study following things. Following points. Instead of things, we will say we are going to study following points. Means which point we are going to study first of all for all processes. First point is we are going to study condition. We will see what is that one, what is meant by condition. Second point we are going to study PV diagram, pressure volume diagram. Then
Okay.
C point, third point, temperature entropy diagram. T, yes, T stand for temperature, S stand for entropy. TS diagram, temperature entropy diagram. 1 minute, I have missed one point here. 1 minute, I have missed. That is the very, very important. B point is what? A equation of state. What is B point?
Equation of state.
Then C point is a PV diagram and D point is a TS diagram. E point? Boundary work relation. What is E point? E point is what? Boundary work relation. Then F point, first law relation. What is first law relation? We have seen boundary
Okay.
work relation means W. First law relation means what? What is first law relation? Q minus W is equal to delta U. That is what we have studied.
Yes.
And
Yes,
G
sir.
point is what? Change in entropy relation. So we are going to study 5 processes, and each processes we are going to study these 7 things.
Okay.
Change in entropy relation. We are going to study these 5 processes, and for 5 processes we are going to study these 7 things. For each process we are going to study constant volume process. We are going to study 7 things of this constant volume process. Then constant pressure process, we are going to study these 7 things of constant pressure process. So please write down this discussion. Now the first process that we are going to study is what?
Constant volume process.
Yes, first process that we are going to study is what? Give the now heading. Constant volume process. First process that we are going to study is what? Constant volume process. Another name for constant volume process is what? Isochoric process. Or sometimes we may also say isometric process. So give the heading constant volume process or isochoric process or isometric process. Now in that, what is our first point? A point is what? A condition. What is A point? A point is a condition. What will be the condition? Here volume is what?
Volume will be constant.
Okay, if volume is constant, it means what? Initial volume is equal to final volume.
Yes.
And their ratio V2 by V1 will become what?
1.
Means same. So volume
Yes.
ratio will become what? Of 1. Please write down the condition. That is A point. Now here a B point will be what? What will be the B point?
Equation of state.
Equation of
State.
state. What is the generalized equation of state? We have seen P1 V1,
Yeah.
P1
Is
V1,
equal to P2 V2
P2 V2.
by T2.
Now here for constant volume process V1 and V2 is the same.
T2 sir.
Sorry, P1 V1 by T1 is equal to what? P2 V2 by what?
T2.
T2. And here, so what is the same for constant volume process? This V1
Volume is constant.
V2. So we can cancel this V1 and V2. And what is the
Yes.
relation will become equation of state for constant
P1
volume
by
process?
T1 is equal to P2 by T2.
P1 by T1 is equal to what? P2
P2
by
by T2.
T2. So please write down this discussion. Now C and D point, always try to write down C point and D point, that is PV diagram, and D point is what? TS diagram. Always try to draw PV and TS diagram side by side. What is meant by PV diagram? Pressure volume diagram, and TS diagram means what? Temperature entropy diagram. So always try to draw the pressure and volume diagram and temperature entropy diagram side by side. Always try to remember this rule. Pressure volume diagram, and the next one will be what?
TS diagram.
Temperature entropy diagram. And always try to draw pressure volume and temperature entropy diagram side by side. That is what a golden rule. We have to remember this. So first of all we will see pressure volume diagram. Here what is pressure? Volume constant. In case
Volume
of the
constant.
constant volume process, volume is a constant. So how to draw the line here on this one? Volume constant means what? V is constant. So line will
Yes.
be what? Straight. How will be
Vertical
the
lines.
straight vertical line? Here now I am going to discuss 2 scenarios with you. So first scenario is what? 1. 1 to what? 2. Okay. First scenario is what? 1 to
1
2.
to 2.
Okay. What will be the first scenario? 1 to 2 will be what? So 1 to
At a
2.
constant volume, the pressure increases.
So constant volume. Here what is happening in this 1 to 2? Tell me. What is happening?
Pressure is increasing.
Pressure is increasing. Okay. This is what one scenario. I am going to draw another scenario. See the things here. In this scenario, what is going to happen? Okay. 1 minute. That is a reverse of the first scenario. So another scenario. 1 to 2. And here what is happening in this scenario? In this second
Pressure
scenario.
is decreasing at constant volume.
Okay, so pressure is decreasing. Now tell me, in which scenario, out of these two scenario, which one is heating and which one is cooling? Out of these two scenario, which one is heating and which one is cooling?
So first part is heating.
Okay, because if you remember our example of pressure cooker is the best example for the constant volume process. So if we add the heat, if we give the heat to the pressure cooker, what is going to happen? Inside pressure is going to increase. So inside pressure means what? Here this scenario is what? Heating scenario. And heating means what? What is the meaning of heating? Heat addition.
Adding.
Okay.
Yes.
And another scenario will be what?
Heat rejection.
Cooling. And cooling means what? Heat rejection. So if you observe, if you keep the pressure cooker for the cooling, then what is going to happen? Pressure is going to what? What happened to this pressure? Pressure is going to reduce. So same scenario will be here. Now if you remember our discussion few hours before, okay, in last session, what we have seen? Due to heat addition, what happened to the entropy? Due to heat addition, entropy increases. Due to heat rejection, what happened to the entropy?
Entropy decreases.
Okay, so means what? Due to heat addition, what happened to the temperature entropy diagram? That is what a TS diagram. During heating or heat addition, constant volume, how will be our TS diagram? Our slope will, temperature and entropy both will increase.
Yes. Inclined line.
Inclined curve like this.
Okay.
Okay. So here we will have a curve. Huh? This will be what? A inclined curve.
Yes.
1 to 2. And this scenario is what? Our heating scenario. Now reverse of this one. In case of the cooling, what is going to happen? Temperature and entropy both is going to reduce.
Yes.
Entropy. Why entropy is going to reduce? Because of the heat rejection. Huh?
Yes.
Because of what? Heat rejection. So here this 1 to 2 is what? What has happened to in this 1 to 2? This 1 to 2 scenario is what?
Entropy decreasing.
Cooling scenario. In case of heating, what is there?
In case of heating,
heat addition. Entropy is going to increase and temperature also going to increase. In case of the cooling means what? Heat rejection scenario.
Yes.
In case of the heat rejection scenario, temperature also going to reduce and entropy also going to reduce. Please draw this PV diagram and TS diagram. Now, what is the E relation we have here? What is the E relation we have here? Boundary work relation?
Yes.
E relation is what? What is our E relation?
Boundary work relation.
Boundary work relation. Boundary work relation means what? W. Okay. So, boundary work relation, what will be the boundary work relation? We will have. Now, in case of the constant volume constant means what? What about? See, if you remember our piston cylinder arrangement discussion from our theory, if you remember our piston cylinder arrangement discussion from a theory, if you remember our discussion, see, I have drawn one piston cylinder arrangement. 1 minute. Piston cylinder. Suppose if this volume is constant, this piston means what? This piston means what? Moving boundary. This piston means what? Moving boundary.
Yes.
If volume constant means what? Is it boundary moving?
No.
It means what? Is there any work?
No.
No. So whenever we have a constant volume process, whenever we have what? A constant volume process, as there is no motion of the boundary, as there is no movement. See, work is always related with motion. Constant volume means no motion. So no motion means what? What about work done? Work done will become what? 0. No motion means what? Work done will become what?
0.
0. Boundary work relation, W will become what? 0. Please write down E point.
So what was the wording you said? As there is no volume change.
Because V is constant, no motion of boundary. And what is the meaning of no motion of boundary? No motion of boundary means what? If there is no motion, then what is going to happen? Work is related with what? No motion of boundary means what? Work is related with what?
Work is related with motion.
Motion. If there is no motion, is there any work?
No work.
Okay. So that's why we have said W equal to 0 for the constant volume process. Then our F point, what is F point? First law relation.
Yes.
What is F point? F point is what? A first law relation. And what will be the first law relation? What is first law relation? We have seen Q minus W is equal to
U.
Q minus W is equal to what?
U.
Delta U. Q minus
Delta
W
U.
is equal to not only U, change in internal energy. Q minus W is equal to what? Delta U. And here,
Yeah.
what about this W? In this case,
It is equal to 0.
Okay,
So delta U is equal to Q.
so in this case, in this scenario, this W is what? W is what? A 0. So can I say
Zero.
make it as a 0? So what Q will
Yes.
become what?
Q will be equal to delta U.
U. And we have seen change in change in internal energy for a ideal gas. For an ideal gas, what is the relation of change in internal energy for an ideal gas? If you remember our discussion, change in internal energy for an ideal gas, what it will become change? Change in internal energy for an ideal gas. What is we have seen? Change in internal energy for an ideal gas.
Yeah, M into CV into T2 minus T1.
mCV T2 minus
T2 minus T1.
T1. So can we replace here? Can we replace
Yes.
here?
Yes.
mCV
T2 minus T1. Yes, sir.
mCV T2 minus T1, and unit will become what then? Kilojoules. Okay. So this relation, from this relation, what we will get? Above relation is used. What is we will say? Above relation is used to find out, what is we will say? Above relation is used to find out heat transfer, is used to find out heat transfer for constant volume process. What we will say? Above
Heat
relation
transfer
is
for
used to
constant
find out
volume process.
heat transfer for what?
Constant volume process.
Constant volume process. Okay, please write down this discussion. Okay, completed. Now
Yes,
what will be
sir.
our G point? Our G point
G
will be
point
what?
is change in entropy relation.
What will be our G point? G point will be what?
Change in entropy relation.
Change in
Entropy relation.
change in entropy.
Relation.
Change in entropy relation. So change in entropy. So what is our generalized change in entropy relation? First
Delta
one.
capital S is
Yeah.
equal to M into CV
No.
into
Change in entropy. I am not saying change in enthalpy. Change in entropy. Generalized change in entropy relation for a closed system containing an ideal gas. If you remember our discussion, change in entropy relation for a closed system containing an ideal gas, we have seen after the specific properties. Change in entropy of a closed system containing an ideal gas, mCv ln T2 by T1. We have seen this relation.
yeah, I was saying the same thing, sir.
Okay. So change in entropy
CV
ln
into ln T2 by T1
T2 by T1
plus R ln
plus R ln
V2 by V1.
V2 by V1.
V1.
Now here,
V is constant, so V2 by V1 will be equal to 1
so mCV, so we can say ln of what? T2 by T1
plus
R into what? ln of V2 by
1.
V1 means what? ln of 1,
Yes.
because here V2 by V1 is the same, V2 and
Yes.
V1 is the same, so V2 by V1 by 1, and ln of 1 will become what? Tell me everyone.
0.
So this term will become what? This term will
Zero.
become what? 0.
That term will become 0.
So whenever we want to find out change in entropy for a constant volume process, the relation will become what? mCV
CV ln T2 by T1.
T2 by T1, and unit will become what? In kilojoule per Kelvin. So whenever we have to find out change in entropy relation for what? Constant volume process, then delta S will become what? mCV ln of T2 by T1.